When solving trigonometric equations, we need to recall firstly the unit circle, and we need to be aware of where the trig ratios are positive and negatives, and we used all stations to central. So all trig ratios are positive in the first quadrant, sine is the only one that's positive in the second, and so on. And then we also need to recall our two special triangles, one root 2, and that's the 45-degree one, and then the other one is 60, 30, and then we've got 1, 2, root 3. So we need to be very familiar with that, and also we need to be able to very quickly go from degrees to radians and know what 30 degrees is in radians, pi on 6, etc. Okay, so having said that, let's look at the first one here. We've got the cos of this angle we're trying to find is 1 on root 2, and we know this is the domain, all the possible values of theta. And you say, well, okay, hold on now, I know what 1 on root 2 is one of the special triangles, so we'll put it down here. And we've got 1 root 2, and we've got 45 degrees, so that's pretty easy. And the cos of 45 is 1 on root 2. So we can say that theta equals 45 degrees. But that's only in the first quadrant. That's not the complete answer. We've only got half the answers. We know that cos is positive in 2 quadrants, so probably it's a good idea to draw a unit circle. And we've already established that the cos of 45 is 1 on root 2. Now this is what we call the basic angle. We know that that's going to be used. We do our all stations to central. So we've got these 2 quadrants here where cos is positive. So we're going to get 2 answers. Not only do we get 45, and you may recall from previous work that you always work off the horizontal axis, which is the x-axis. So this is 0 plus 45, or all the way around there and come back 45 degrees. So there are 2 answers, 45 degrees or 360, which is going all the way around, and then you come back 45. That's not really nice putting all that there. And 360 minus 45 is 315 degrees. So just going through the steps again, we find the basic angle in the first quadrant. Forget about what sign we've got here. So we know that 1 on root 2 is one of our special triangles. So we've got 45 degrees in the first quadrant. You then draw your unit circle and all stations to central, and that will say, okay, our trig ratio is positive for cos. So we've got this quadrant here, and we've got this quadrant here. So not only in the first quadrant, but also in the fourth quadrant are we going to get an answer. Always work off the x-axis, the horizontal axis, 45 degrees, or 360 minus 45, which is equal to 315 degrees. So theta equals 45 or 315. Now that's because theta's got to lie between 0 and 360. If I said theta lies between 0 and 180, you'll only get one answer. So all we're interested in is this region here. and there is only one quadrant where cos is positive, and that's in this quadrant here. The other one is down here, which is not between 0 and 180. So you would only get one answer in that quadrant, so you'd get theta equals 45 degrees. Okay, so let's have a look. Oh, we've got a straight line that's come in here. Let's have a look at this example here. And we're asked to find all values of theta where cos of theta is equal to minus 3 on root 2. And once again, those combination of numbers probably are going to do with one of the magic triangles or one of the special triangles. So this is 2, this is 1, this is 60, this is 30, and we know that's root 3 there. So which angle in this triangle has a cos of root 3 on 2? It's adjacent over hypotenuse, so it's 30 degrees. So if we draw our unit circle, and we've got, another way to remember it is C-A-S-T, cast, but we start down there when we do that. So our basic angle is 30 degrees. Okay, so that's our basic angle. So first of all, we find what angle cos of alpha equals, forget about the sign, we'll just go root 3 on 2. This is not our answer, this is just what we call our basic angle. So if we know, forget about the sign there, so we know that the cos of alpha is root 3 on 2, root 3 on 2, so alpha is equal to 30 degrees, and this is the basic angle, not our answer. But this will allow us to work out our angle. So the basic angle is 30 degrees. Now, obviously, cos is positive there. We want cos negative. Cos is positive in the fourth, cos is positive in the first. So cos is negative in these two. Cos is negative in those two. Our basic angle is 30. So we work 30 degrees off that way and 30 degrees off that way. So in the second quadrant, so therefore theta is equal to get this angle here, we go all the way to 180 and then take 30 off. Or, there's another possibility, it's this angle down here. Maybe if I just do it in red. That's the second possibility. In there, cos is negative. And to get to that angle there, we go round to 180 and then add on the basic angle of 30 degrees. So this is 30 and that is 30 in there. So this angle here is 180 minus 30, which is 150. And this angle down here is 180 plus 30. We can simplify those two, 150 degrees or 210 degrees. So they are the two possibilities between 0 and 360 where the cos is equal to negative. Okay, so that's the basic approach. I'm going to come back and do some more examples in the next few videos, and these are things that by now hopefully you are very, very familiar with, because without that knowledge it's going to make it very difficult learning to solve trigonometric equations.